So it's been a while since we talked about the trace of a matrix. The trace of a square matrix is just the sum of its diagonal entries. So for this square matrix right here, to take the trace, I just look at the diagonal entries here, 3, 2, and -1, add them up, and I get 4. Okay, so let's now look at the collection of all, say, 2 by 2 matrices such that the trace of A is equal to 0. Okay, well then let's see. So is V a vector space? Well, let's see. Is 0 an element of V? Well, since we're in M2, 0 looks like the 2 by 2 0 matrix. And so if I want to take its trace, I add up these numbers along the diagonal, and I see that the trace of the 0 matrix is indeed 0, so that's fine. Now what about if I take 2 elements from V? So V consists of 2 by 2 matrices, so let's call them B and C. All right, so let's say let B and C be elements of this collection of 2 by 2 matrices. Okay, so then by this criterion here, that the trace has to be equal to 0, we know that trace of B is equal to 0, and we know that the trace of C is equal to 0. All right, so what does that mean? Well, so B then has to look like something where now there's stuff here and there's stuff here, and I don't know what they are, but they have to cancel out when I add them together. So if this is B up here, then this has to be minus B down here. Now, what's off the diagonal? Oh, who knows? There can be anything here. There's no restriction on what goes on here and here. But I also know that C has the same form. It looks like little c here and minus little c here. They have to differ by a sign. Now that's not saying one or the other is definitely positive, but whichever's which, they have to have opposite sign. So, okay, if we look at B plus C, then all we need to check about this is what happens on the diagonals. And so, let's see. So we have, you know what? Let's go back. I'm going to rewrite this as B11 minus B11 and B12 and B21 and C11 and minus C11 and C12, C21. Okay, so now everything's a little bit more definite. There we go. Okay, so if we look at the sum of these guys, we have B11 plus C11, B12 plus C12, B21 plus C21, and then here we have minus B11 minus C11. So that's the new and exciting part from this particular form of the matrices that we're restricted to working with. And so if I look at the trace of B plus C, then you can see that this is going to be B11 plus C11 minus B11 plus C11, and it's going to give you 0. And if I take a scalar multiple, let's not call it C, let's call it alpha, so my scalar alpha. If I multiply B by the scalar alpha, then what do I get? Well, I'm going to have alpha B11, alpha B12, alpha B21, and alpha B11 negative. And then the trace of alpha B is going to be alpha B11 minus alpha B11, which is 0. So the collection of matrices of trace 0 known as trace 0 is a vector space.